Hey guys, I am really excited because this is the first A-level maths video that has gone up on my channel. We've been working incredibly hard on this, and in this video the lovely Mr. B is going to be taking you through the laws of indices that you need for your AS and your A-level maths. Lots of examples in here that hopefully you're familiar with from GCSE, so this might just be a little bit of revision, or this might be learning something completely new. There are 3 different levels of questioning here, and you can use the timestamps in the description to jump between them. You can use this at your own pace. You can go straight for the hard questions, and if you find them too easy, then go back to the medium or the easy questions. No one's going to judge you for how hard or easy you find this, or how long it takes you to go through this video. Now, if you want a load more practice questions, then they're all waiting for you over my website.
We are going to have a look at the laws of indices, and the first law is that you have a number and you're multiplying it by another number. Then if those numbers are both the same, so they're both n, the same number, the powers on those numbers can be added together to simplify it. So n to the power of a multiplied by n to the power of b, altogether will be n to the power of a plus b. Now, how does that work? Well, let's have a look at an example. Let's have a look at a q to the minus 2 times q. They both have the same base. They both have a q. That means that we can use this rule. If these were different letters or they were different numbers, then we wouldn't be able to use this rule. Then we look at the powers. Now, the first q has got a power of negative 2. The second q doesn't have a power. A little extra law here. If you see something where there's no power, it's power 1. We have a negative 2, we have a 1, so we're going to add them together. Altogether, that will give us q to the power of negative 1. Now, I've told you what the law is, and we've used the law. All we did was take the negative 2, add 1 to it, and we got negative 1. But why does this work? So let's have a look at that next. Let's say we had q to the power of 2 multiplied by q to the power of 1. What does q to the power of 2 mean? Well, it means q, I've got 2 of them, that's why it's a power 2, and they're being multiplied together. And then we've got the times q. So altogether, you can see that q squared times q. Altogether, I've got 3 q's. And if you've got 3 q's altogether, then you can write just 1 q and show a little 3, a little power of 3 that shows actually that represents 3 q's multiplied together. And you'll notice that power 2 and power 1 altogether will make power 3 if you add them. That's where this shortcut comes from. Now, what about the question we looked at with q to the power of negative 2? What does that mean? Q to the power of negative 2 means 1 over q to the power of 2. And so as another extra little rule here, as well as q with no power being just q to the power of 1, when you've got something that's a negative power, for example, q to the power of negative 2, you can swap the negative symbol in the power for a 1 over fraction. Give it a numerator of 1, and that makes the negative become a positive. Now we'll look at that in future examples. Then if we multiply that by q, that gives us q divided by q squared. And we've already discussed that q squared is equal to q times q. And now what we can do is we can cancel out this fraction. We can do q divided by q is 1. And that leaves us with 1 over q. And like we discussed with the negative power being a fraction with 1 as a numerator, here we've got a fraction with 1 as a numerator, so we could write it as q to the power of negative 1. Because with q, it's the power of 1 on the denominator. If you bring it up to the top, you get a negative number. We can see what the shortcut is. If you add together the powers, you get your answer. But hopefully now as well, you've got some insight about why that's the case and how that works. And a couple of the extra points were that a number without a power is to the power of 1, and a negative power, such as negative 1, becomes 1 over n to that power. And rather than write 1, let's generalize it. So let's write a for that, because this is going to work with any power. N to the power of negative a will become 1 over n to the power of a. Now, for our second index law, we're going to look at divides. So our first one, if we multiplied the same base numbers, you can add the powers. With this one, if you divide the same base numbers, So n and n, a number, the same number. Then the powers a and b, you take them away. So let's test that out on our question. So we have z to the power of -5, and we're dividing it by z to the power of -2. So the first thing to notice is they both have the same base number, z. So we can use laws of indices. If they weren't both the same letter or number, then we wouldn't be able to do this. So then let's take a look at the powers. So we've got -5 and -2. Write them both down first and leave a gap. Now it's a divide, so we're going to take them away. So write the takeaway symbol in the middle. If you do it this way, you'll see we've got a double negative actually. So it's -5, take away -2. The double negative is going to be a plus. So it's actually going to be -5 plus 2, which will give us -3. So now we know what the power is going to be. It's going to be z to the power of -3. And using our extra law around negative numbers, we could write it as 1 over z to the positive power of 3. Either form is fine. Usually, in a question like this, the -3 will be absolutely fine. But some questions, we have to use this as part of something else. Then you need to know both forms, because one might be more useful than the other if you need to do more calculations afterwards. Now, again, we'll spend a little bit of time at looking at kind of how this rule works. So let's say we had z to the power of 5 divided by z to the power of 2. So what does z to the power of 5 mean? Well, it means you've got 5 z's altogether multiplying by each other. And what does z to the power of 2 mean? Well, that means you've got 2 z's multiplying together. And we are dividing them by each other. So where does z to the power of 3 as an answer come from? Because you take away the powers, you're going to get the -3. How can we show that's actually the case? So what we do is we have a look at our fraction and we're going to cancel some out. Z divided by z is 1, and the other z divided by z is 1. And that leaves us, for the numerator, z times z times z times 1 times 1. Now we can safely ignore the multiply by ones, because if you multiply something by 1, you just stay with the same number. So the important thing to look at here is that we have 3 z's being multiplied together left over. So that's where the z to the power of 3 comes from. But again, you don't need to worry about that. You can just know the shortcut, where if the base numbers are the same, you can take away the powers. Let's look in more detail about how our original question would work like this. We have z to the power of -5, and so that means 1 over our 5 z's being multiplied together. And then we're dividing it by z to the power of -2, which is 2 z's to be multiplied together. Because it's negative, it's going to be 1 over that. Now, the key to this is remembering how dividing fractions work, because these are both fractions. And if you want to divide fractions, what you can do is you can change the symbol to a multiply. So we're using the opposite symbol. But if you do that, obviously we'll get the wrong answer. So what we need to do is do the opposite somewhere else to cancel it out. And so we can do the opposite of our second fraction. Instead of dividing by 1 over z times z, we can flip it upside down and times it by z times z over 1. So we've kept the first fraction the same, we flipped our symbol, and then we flip the second fraction. The two opposites cancelling each other out, so we still get the correct answer. If you multiply that together, we've got 2 z's being multiplied together on top, we've got 5 below, and again we can cancel out. So we can do z divided by z is 1, and z divided by z is 1, and altogether that's going to give us 1 over 3 z's multiplied together, which gives our answer z to the power of -3. So again, we've got our shortcut, which is really quick and easy to use. You just get the powers -5, -2, and you take them away from each other. That gives you -3. However, going into more detail, you can see where that shortcut comes from, because if you do the maths in a full amount of detail, that's the answer that you get. Now, our third law involves multiplication. So if we have a base number, n, and it's to a power, if we have brackets around this and we raise it to a second power, that's the same as our base number having the powers multiplied together. If we have a look at our question, we've got c to the power of -8 to the power of 5. So it's the 2 powers. Now, you don't have to worry about matching base numbers here. We've just got the c, that's fine. But then if we look at the powers, we've got -8 and we've got +5. So we multiply those together, and that gives us -40. Altogether, to the 2 powers, c is going to be to the power of -40. Now, again, we'll go into a little bit of detail of how this works. Now, power 8 actually be quite big, so let's do one a little bit smaller. So let's do c to the power of 2, then raised to the power of 3. So how does this work? Well, c to the power of 2 means c times c. The power 3 means that we're going to do that 3 times. So we're not going to do c times c once, we're going to do c times 3 times. Then you think, well, how many C's do we have altogether? We have 6 C's altogether. That will give us c to the power of 6. So when we look at our original question, c to the power of -8, that'll be 1 over 8 C's multiplied together. If you then raise that to the power of 5, all that means you're doing is you're multiplying that 1 over c to the power of 8 by itself 5 times. And so you end up having 5 lots of that 8, which gives you -40. And again, if you choose, you could write that as 1 over c to the power of +40. So if you look at negative numbers, you can get rid of them, but the trade-off is you end up with a fraction instead. Now, for our next question, we've already gone through the rules for this. We've got 1 over p to the power of 5. That's going to be the same as p to the power of -5. So again, you can swap the fraction for a negative number or the other way around. Now, as an additional question here, what if we had 1 over p to the power of -5? It's already negative, so what would happen if we got rid of the fraction? Well, what we get is p to the power of +5. So what's happening here isn't exactly that you are swapping the fraction for a negative power, so it's a fraction becomes a negative, it's changing the sign. So if it's over a positive number, it'll become a negative number, like our first example. But if it's over a negative number already, and you make that negative, you get a double negative, which will make it a positive. Next, you might have noticed that we have a law where you add the powers, subtract the powers, and multiply the powers. So is there a law where we divide the powers? And there is. And the way it works is, again, we've got a base number, which we can call n in this case. And this is all about if you have a square root or a cube root or something similar. If you've got a power a on n, and then the root is going to be to a power as well, then you can change that into a divide. So we have a look at our question. We've got root d to the power of 4. And again, with this law, we don't really need to worry about base numbers being the same. There's only one base number to look at. And you'll notice there's no number on the power for our base. So what do we do there? Well, with a root, if there is no power, you assume it's a power 2, a square root. If it's a cube root, there'll be a 3 there. You know, if it's to the power 4 root, there'll be a 4 there. But if there's no power, it'll be a square root. So then if we have a look at our formula, so it's n is going to be a divided by b. So our base number n will be d in this case. Our power a is 4, and then our root b is 2. So you write a fractional power, and the power is the numerator, and the root is the denominator. Now, sometimes you leave these as powers, but in this case, we can do 4 divided by 2. 4 divided by 2 is 2. That gives us d to the power of 2. Now, you might be wondering how this works. Okay, we'll have a look at our example in more detail. So d to the power of 4, and we're square rooting it. The d to the power of 4 means we have d times d times d times d. We have it 4 times. And the square root symbol means that what we want to do is have a number that's multiplied by itself, but we just want to know what one copy of that is going to be. So what we need to do is cut this in half and make sure we have the same thing on both sides. So I've almost drawn a line of symmetry through this, but at each side, we've got d times d. So I only want one of these, which is d times d, which is the same as d squared. Let's just see that number works with normal numbers. So let's say we took the square root of 16. 16 is equal to 4 times 4. If we draw a line of symmetry through 4 times 4, we have the same thing on both sides. We can see we have 4 on one side. So the square root of 16 is 4, which is something you should be really confident with already. So we just look at kind of one side of the repeated calculation. So the square root of d to the power of 4 is actually d squared. So we've gone through the 4 main laws of indices, and we've got 2 extra ones. N is the same as n to the power of 1. N to the negative a is equal to 1 over n to the a. There's one extra one I want to add here, which is n to the power of 0 is equal to 1. So that's a bit of a weird one, and we'll just quickly go through that. Let's say we have 2 to the power of 0. We want to know what 2 to the power of 0 is. So we could look at 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3 to help us. So 2 to the power of 3 is 8, 2 to the power of 2 is 4, and 2 to the power of 1 is 2. Now have a look at the pattern here. Each time we are dividing by our base number. We're dividing by 2 each time. So when we get to 2 to the power of 0, we follow this pattern and divide by 2 again. 2 divided by 2 gives us 1. This also explains the negative number thing, because when we look at the negative numbers, we're going to continue to divide by 2. 1 divided by 2 is a half. A half divided by 2 is a quarter, and another way of writing a quarter is 2 to the power of 2, because 2 to the power of 2 is forced to be 1 over 2 to the power of 2. A quarter divided by 2 is an eighth. And again, another way of writing an 8, the 8 can be written as 2 to the power of 3. So doing a little number pattern like this, if you forget, can remind you what power 1, power 0, and negative powers actually are. And it kind of proves by looking at the pattern in the sequence that these laws are actually true. And that power 1 is the same as just a number, and power 0 is the same as 1. So now let's have a look at some more complicated questions. Our first question, we see is a multiplication. So we're going to use a multiplication law, but it doesn't exactly look like what we have there with a base number and powers. We've got more things here. Now we have base numbers. We've got a t on both sides. So t is going to be our base number. Now what we need to do is split this into 2 sections. We're going to use the laws of indices with our base number t. And then with the other numbers, we're just going to use normal number rules. For our first pair, we'll look at the normal numbers. We've got 4, we've got -7, and it's a multiplication. So 4 times -7 is -28. So that's our kind of normal number section done. Now we look at the powers. We've got t to the power of -7 and t to the power of 4. So we've got -7 and 4. The base numbers are the same, they're both t, so we can use laws of indices. If we multiply, we need to add the powers together. So we have -7 plus 4, which should give us -3. So in our final answer, we can write -28 t to the power of -3, and then that would be our final answer. Now, that method is consistent across the index laws. So if you have some base numbers, in this case f, and you've got some extra kind of normal numbers at the start, then you do it in 2 sections. You do the normal number rules first. So we've got -5 divided by -6. That's going to give us negative divided by negative. The negative will cancel out. Then we've got 5 divided by 6. That'll give us a decimal, so we can just leave it as a fraction. We're doing 5 divided by 6. Then we use laws of indices with our base numbers. We've got f to the -5, so write down -5. F to the -7, write down -7. And looking at our laws of indices, that we're dividing. So we're dividing our base numbers, we take away the powers. That gives us -5, take away -7. We've got a double negative, so that'll be -5 plus 7, which will give us 2. So in our final answer, we can write f to the power of 2. So we have 5/6 of f to the power of 2 as our final answer. With the next question, again, we've got our base number. This time it's L, and it's the power of -8. And it's being raised to a second power, -1. We can see again, we've got a normal number at the start. So again, we do this in 2 sections. So the first section, we're going to do 4 to the power of -1. Now, we've already gone through something to the power of -1 can be changed into a fraction. So 4 to the power of -1 will be 1 over 4 to the power of 1. And then if anything's to the power of 1, it's just the same number again. So we don't need to write the power there. So 4 to the power of -1 is actually the same as 1/4. Next, we're going to have a look at the powers. So we've got L to the power of -8, and then we've got the -1. And if you've got 2 powers with a bracket in between, then those powers being multiplied by each other. So -8 times -1 will give us a +8. They'll give us a quarter L to the power of 8. For our next question, we've got y to the power of 3, but again, we've got a normal number getting involved as well. So we have the 5 to look at. Then we can have a look at the y to the power of 3. Now, this is the denominator of a fraction. So read this the same as 5 and a 1 over y to the power of 3. So we can kind of write it as a multiplication like this. Now, y to the power of 3 it's 1 over. So what we can do is we can write it as y to the power of -3. So we get rid of the fraction and the numerator 1, then we can change it into a negative power. We can change the sign on the power. All we need to do is write the 5 at the start. So essentially, if it's not, a fraction where it's 1 over, then that extra number, you just write that at the start. It's going to work the same way as if it was 1 over y to the power of 3. Now, moving on to our last question like this, again, we've got a base number with a power, and we've got another power involved as well. And we've got a normal number in here as well. So again, we do it in 2 steps. The first thing we'll look at is the 64. And the 64 is going to be to the root of a cube root. So we want 3 numbers which multiply together to give us 64. And that's actually going to be 4. 4 times 4 times 4 is 64. Then we want to find the cube root of p to the power of -3. So there we can use our laws of indices. We're going to write our index as a power. So it's going to be, if you look at the law, a divided by b. The a is the power on the p, which is -3. And that's going to be over b, which is the root, which is a cube root. So that's a 3. So we have 3 to the power of -3 over 3. And we can do 3 divided by 3. 3 divided by 3 is 1. So it's going to be p to the power of -1. So sometimes you leave it as a fraction, but you can simplify the fraction, then you should do so. So bringing it all together, we've got the 4 for the normal numbers, and we've got the p to the power of -1. And again, if you chose to, you could write it as 1 over p to the power of 1, and we've got the 4, so it'd be 4 over p. 4p to the -1 is probably the expected answer, and that'd be fine if it was just this question on its own. 4 over p, the simplification, that might be useful when you have to combine it with something else. So then you have to do another step where 4 over p is a simpler thing to use than 4p to the power of -1. So again, the whole thing with this is, if you have some normal numbers mixed in with your laws of indices, do the laws of indices as normal and then use the normal rules on the normal numbers. If it's multiplication, multiply them. If it's division, divide them. If it's a second power, the number's going to go to that power. And if it's a root like this, then you have to take the normal number to the root. You can't just leave it as 64. One type of more difficult question can have multiple sets of terms to use laws of indices with. So for example, this one has got 3 terms rather than 2. So again, all you need to do is split it up into bits where laws of indices apply, so your base number and the powers, and then bits where your normal numbers will apply, so the 5, the 6, and we've got a -1 there as well. So we just do it in 2 parts. We do 5 times 6 times -1. Now notice there's no 1 there, but if you just have in algebra, a letter on its own, we've got 1 lot of it. Now, normally multiplying by 1 won't make a difference, but it is a negative, so that will change it. 5 times 6 is 30, and 30 times -1 is going to be -30. Then look at the powers. We've got power 6, power 4, and power 2. It's all being multiplied, so we're going to add them all together. So altogether, 6 plus 4 is 10, plus the 2 is 12, so that's going to be n to the power of 12. So altogether, we have -30, n to the power of 12. Next, we have another example with 3 terms. So again, just pick out your laws of indices and your normal numbers and do the 2 sections separately. Normal numbers first. So we're going to have 2 divided by -4. Now, it might be easier to write these as fractions. 2 divided by -4, that's going to simplify down to -half. Then we're going to have a -half divided by -3. Now, it's difficult to write that as a fraction since one part of it is already a fraction. What we could do is write 0.5, -0.5 over -3. Now, using equivalent fractions, we could double this to get whole numbers, and that would be 1 over 6. And the negative numbers, the top and the bottom are both negative, so they would cancel out and give us a positive. So that would actually give us 1/6. Then we'll look at the powers. Write them down first, -8, 7, and -3. And then all of these are divides, so we're going to put a minus in between. Also, note you can have a combination of times and divides. You could have a thing where you put a plus in there and put a minus in. Now I've got a double negative, so this would be -8, take away 7, plus 3. -8, take away 7 will give us -15, and then add on the 3 would give us -12. So bringing it all together, that would give us a 6th for our normal numbers, and then to the power of negative 12 for our indices. Another situation you might come across is where you have multiple letter terms. So for example, in this one, we've got t to the power of 9 and t to the power of 5. So they've both got the same base numbers, so we can use laws of indices. But then we've got the s to the power of negative 2 and s to the power of negative 4. They're both the same base number s, and so they can use laws of indices as well. So we do them separately. So the t to the 9 and the 5, right, they're the powers. It's a multiplication, so we're adding the powers, and 9 plus 5 is 14. So that would give us t to the power of 14. Then we do the s. We have negative 2 and negative 4. They'll also be multiplied, so we add those together. A plus and a minus together will be a minus. So negative 2 plus negative 4 will give us negative 6. So that'll be s to the power of negative 6. Now, again, that should be acceptable as a final answer, but you might be asked to write it in a certain format, or you might need it for a further calculation. What might be helpful is you could write it as t to the 14 over s to the 6. What we're doing here is we're changing s to the minus 6 into 1 over s to the 6. Then we're essentially multiplying together 1 over s to the 6 times t to the 14. So if you've got a fraction and you multiply it by something, the thing you're multiplying by can just fit on the numerator like this. So that form might be easier sometimes. Now, a common mistake here is then going to be to continue and do something like t to the power of 8. Because you're looking at a 14 and a 6 being divided, you might think you have to take away the powers. But you can't do that. It's not allowed. And the reason for that is the base numbers are not the same. We have a t and an s as the base numbers on these indices. That means we cannot use the laws of indices. And so we need to leave the answer as it was. Our next example also has two sets of base numbers. We have the e's, e to the power 2 and e to the power 9, and the s's, s to the power 3 and s to the power of negative 1. And again, we just do the two separate base number sets separately. So with the e's, we've got power 2 and 9, and it's divide. So in laws of indices, we're going to take these powers away, giving us negative 7. That would be e to the power of negative 7. Looking at the s terms, we've got 3 and negative 1. It's a divide. We take the powers away. It's a double negative. It'll be a plus. 3 plus 1 is 4. That will give us s to the power of 4. So again, doing the two sections separately, it's nice and quick. Again, you might want to write it in a certain format at the end. You might want to say that we're going to have the positive power as the numerator and the negative power as a denominator of a fraction, changing e to the power of negative 7 into a fraction 1 over e to the 7. Then you've got 1 over a fraction, you multiply it by the s to the 4, you can pop that on top. Our last question is another with two base numbers. We've got d to the power of 6 and we've got v to the power of negative 7. And what's happening here is both of these are being raised to a second power, negative 2. So we do these separately. Now, when you raise to a second power, it's going to be a multiplication. So let's look at the d first. We've got 6 and the negative 2. We're multiplying them. That will give us negative 12. So we can write d to the power of negative 12. Then we can look at the v. We've got negative 7. And again, we're reusing this negative 2. It's happening to both of them. Multiplying together, negative 7 times negative 2 is a positive 14. That gives v to the power of 14. You can write that as your answer if you like. You can write it in a different format. We could write it as v to the power of 14 over the d to the power of 12, swapping the negative symbol for a fraction instead. And again, which of those two answers you write will depend on the context. You might be asked for it in one of those formats, or the next part of the question might be easier with one of those formats used. But both of them are correct.
Ouch! This is why in some videos I have unexplained scratches.